Alright, so in this video we're going to talk about functions and their graphs. So the first thing that we need to discuss is this idea of domain and range. So domain is simply just x values that you plug into any function, and sometimes we call those the input values. The y values are our range, and a lot of times you'll hear those referred to as the output values. Now, our first essential question that we're going to answer today is how can you determine if a relation is a function? Before we do that, we need to talk about what a relation is. And that is any set of ordered pairs. There's no restrictions on what they are. So you could have like 1, 2, 1, 8, 2, 3. That's just a set of random ordered pairs that's a relation. A function, on the other hand, is a set of ordered pairs that has this restriction. Every input has exactly one output. So what I want you to really be aware of is this second bullet point down below. It is not okay for an x value to have two different y values. So if we look at this set of ordered pairs I made above by relation, look at this x value. We're saying if we plug in 1, we get out 2, but now we're saying if we plug in 1, we get out 8. That's not okay. It's okay, however, it is okay for two different x values to have the same y value. So if you had something like 1, 9 and 3, 9, that's all right. You can have the same y value, you cannot have the same x value. Okay, so let's look at our first two examples to determine whether or not something is a relation or a function. So if we look here in our first table, they're saying that -3 goes to 9, +3 goes to 9. If you plug in 4, you get 16. If you plug in 5, you get 25. So the fact that all of your x values are different tells you that it is a relation. Even though you have the same y values, remember, it is okay to have the same y value. So this actually is a function. Okay, next we have this right here, and this is a red flag because they're telling us is 1 gives you 8, but then they're also saying if you plug in 1 to this function, you get out 10. That doesn't work. So this is simply a relation. Now this is a little easier to tell if you're working with graphs. So if we look at our next set of examples, we have this test called the vertical line test, which sometimes you'll see abbreviated as VLT. What that tells you is if a vertical line intersects a graph more than once, it's not a function. So let's go ahead and take a vertical line and put it through the graph. Now notice this vertical line only touches right there. And if we would slide that line across the entire graph, notice it's only crossing the graph at one point. That then passes the vertical line test, and we can say that this is in fact a function. Let's try it on this second graph. So if we pass our vertical line along this graph, notice it's only touching at one spot anywhere on that graph. So again, we can say that this is a function. Now lastly, if we take our vertical line and pass it along this graph, notice that as I'm passing it along, it's not just crossing in one spot because it's crossing right here and it's crossing right here. So again, if it crosses the graph more than once, it is not a function. So we cannot say this is a function. It's simply a relation. All right, so main thing there is if a function has points that are directly above or below each other, or if the graph does, then it's not a function. So let's try that again here. Let's get another vertical line. We're going to see if these sets of ordered pairs create a function or a relation. So if we pass this vertical line along in our first graph, that only hits once there, once there, once there, once there, once there, and when we get here to an x value of 4, notice I have this and this. So that is going to fail the vertical line test because they're saying if you plug 4 into this function, you might get a positive 2 out right here, but if you plug 4 in, you might get a negative 4 out. So that's not a function. That is only a relation. So let's go ahead and try it on our second graph. All right. I don't know where my word went, but that was a relation because it did not pass the vertical line test. So now let's take our vertical line and pass it through our second graph here. So we got 1 point there, 1 point there, 1 point, 1 point, 1 point, 1 point there, 1 point there, and lastly 1 point way up there in the upper right hand side. So notice that that vertical line, only 1 point touched it anywhere we passed it through, so this second graph is in fact a function. Alright, so only 1 point can touch that vertical line in order for a graph to be a function. So that moves us into whether or not an ordered pair is a solution to a function. So we're going to be talking specifically about functions for the last part of our notes. So an equation in two variables is usually the types of equations that we'll work with in algebra. They have an x and a y. So something like y equals 3x minus 4, that's an equation in two variables. To determine if something is a solution to an equation like that, you have to plug in for x and y and see if it makes a true statement. So we're going to figure out, is 2 comma 5 a solution to that equation above, y equals 3x minus 4. So we're going to plug in 2 for x and 5 for y and see if that gives us something that makes sense. So if we substitute, we'll get 5. We want to see, is that equal to 3 times 2 minus 4? So is 5 equal to 6 minus 4? And we can see no, because 5 does not equal 2. So no, 2 comma 5 is not a solution because it made a false statement. One more thing that we will mention from time to time are these things called independent and dependent variables. The independent variable are your x values in an equation, which remember we called those our input values. So independent is input and dependent is your y's, those are your output values. Alright, so let's look at some graphing of these functions.